Hi students, welcome to Math Workshop. Before we start the class, please subscribe my channel first and click bell icon for regular updates. In previous class, we solved up to problem number 8 in exercise 1.2. So today we will start from the question number 9. Okay. So in this question, the function given as f of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is even. So this is the function given. Here this n belongs to n. So this n belongs to natural numbers. So these all n's are natural numbers. Here the function f colon n arrow n. So what is mean by this? This n denotes the domain. This is codomain. What is mean by n? N is nothing but a natural numbers. So there the function given is the codomain and domain are natural numbers. We need to check this given function is one-to-one, onto or bijective and justify our answer also. Okay. So first we need to check the given function is one-to-one or not. So for one-to-one, here the function given as f of n is equal to n plus 1 by 2 and f of n is equal to n by 2. If n is odd, n by 2 if n is even. So this is the function given, right? So for example, I am taking n is odd. So I am taking 1. This 1 is odd only, right? 1 is odd only. This 1 is also belongs to natural numbers because all n's are belongs to natural number only. So 1 is also belongs to natural number only. If I am taking n is odd, that is n is equal to 1. What is mean by f of n? 1 plus 1 by 2 is equal to 2 by 2, that is 1, right? If I am taking n is even, for example 2, that is also belongs to natural number only. So f of n is equal to, what is n is equal to, or even means f of n is equal to n by 2. So 2 by 2 equal to 1. So for two different inputs, we are getting a same output, right? So I am plotting this is in a diagram. This is nothing but n. This is f of n means I am taking f n is equal to 1, n is equal to 2. I am getting a same output, right? So two inputs, same output. So this function is definitely not 1 to 1. So this function is not 1 to 1 function because for a two different inputs we are getting a same output. So this is the reason. Next we need to check this onto. So for onto, what condition need to check? We codomain is equal to range. This is the condition for onto, right? Codomain is nothing but here all natural numbers. So this is the codomain, right? So codomain means all natural numbers. So codomain means all natural numbers. So we need to find the range here. Okay, range is nothing but f of x, right? So f of x, here f of n. So we need to find the f of n values. So here the function given as f of n is equal to n plus 1 by 2 if n is odd, right? What is mean by odd? Odd numbers means n is equal to 1, 3, 5. Up to we can generalize this odd numbers by, so we am taking 2n minus 1. This is the general form of odd numbers. If I am taking n is equal to 1 means 2 minus 1, 1. So 1 is an odd number, right? So here n is also belongs to natural numbers only. So we will start from 1 only. So I am taking n is equal to 2 means 2 into 2, 4. 4 minus 1, 3. So this is odd number. So I am generalizing, I am taking the odd number as 2n minus 1. So f of n is equal to n plus 1. So f of 2n minus 1 is equal to n is equal to 2n minus 1 plus 1 divided by 2. So this cancel 2n by 2. So 2 cancel equal to n, right? So this n all n's are natural numbers only. So this for n is equal to odd. If n is equal to even means, what are the n values? 2, 4, 6 up to, we can generalize 2n because n is equal to 2 to 2 a difference. 2, 4, 6 like that. Okay, so I am commonly generalizing the even number as 2n. So f of n is equal to f of 2n is equal to 2n divided by 2, because if n is even means number f of n is n by 2, right? So 2n by 2, this is also equal to n. So this n also belongs to natural number only, because this question given us all n's are natural number only. So range is also nothing but all natural numbers. So hence we proved codomain equal to range. Codomain also all natural numbers, range is also all natural number. Therefore this function is onto function. So this function f is not 1 to 1 but onto function. Next question number 10. So in this question the given function is f of x is equal to x minus 2 by x minus 3. Here domain and codomain is represented by, domain is represented by A, codomain is represented by B. What is A and B? A is nothing but r minus 3. What is the meaning of this? Means this A values are all real numbers but excluding this 3. So minus 3 means all real numbers excluding 3. So B is nothing but r minus 1. So B is nothing but all real numbers excluding 1. So this is the meaning. Minus means excluding this value. All real numbers excluding 1. All real numbers excluding 3. This is domain. This is codomain. This is domain. This is codomain. So we need to check this given function is 1 to 1 or and 2. 1 to 1 and 2. Justify your answer. So for 1 to 1 function, for 1 to 1 we need to justify this f of x1 is equal to f of x2 gives x1 equal to x2. We need to prove this function f of x1 is equal to f of x2 tends to x1 is equal to x2. We need to prove this equation. So here given is f of x is equal to x minus 2 divided by x minus 3. So f of x1 is nothing but x1 minus 2 divided by x1 minus 3. F of x2 is nothing but x2 minus 2 divided by x2 minus 3. So by cross multiplying x1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. Okay, so by multiplying this two terms, first we need to multiply x1 into these numbers. So x1 x2 minus 3x1. Next minus 2 multiplying with this numbers. So minus 2x1 plus minus 2 into minus 3 is 6 equal to this x2 x1 minus 3x2 minus 2x1 plus 2 into 3 equal to 6. Okay, so next I am taking this term to this side. So x1 x2 minus 3x1 minus 2x1 plus 6. This while taking this term this side, so minus x2 x1 plus 3x2 plus 2x1 minus 6 equal to 0. Okay, so what are the terms we need to cancel? X1 x2 minus x1 x2. So we need to cancel this. Next minus 2x1 plus 2x2. Okay, then next plus 6 and minus 6. So minus 3x1 plus 3x2 equal to 0. So while taking this term to this side, minus 3x1 is equal to minus 3x2. We can cancel minus 3 3. So x1 equal to x2. So we proved x1 is equal to x2. So this function is 1 to 1 function. So we proved this function is a 1 to 1 function because x1 is equal to x2. Next we need to check this onto. Right. For onto we need to prove codomain is equal to range. Right. Codomain is equal to range. Codomain is nothing but y. Range is nothing but f of x. So here f of x is given as x minus 2 divided by x minus 3. Okay, so what is codomain? Codomain is given as, here f is given as a arrow b. So a is domain, b is codomain. B is nothing but r minus 1. So all real numbers excluding 1. Excluding 1 means y is not equal to 1. Y is the codomain, right? So y should not equal to 1. So that is the concept given in this equation. So okay, next we need to prove f of x equal to y. Okay, so f of x is equal to x minus 2 by x minus 3. So y is also equal to x minus 2 by x minus 3. So from this equation we need to calculate the x value first. So we cross multiplying this value, y into x minus 3 is equal to x minus 2. So by multiplying y inside, xy minus 3y is equal to x minus 2. So first we need to calculate x value only. So I am taking this x to this side, this minus 3y to this side. So xy minus x equal to 2 plus 3y, right? Sorry, minus 2. Minus 2 plus 3y. So I am taking x's out common. So xy minus 1 equal to 3y minus 2. So x is equal to 3y minus 2 divided by y minus 1. This is the x value. So this is the x value. Y value is x minus 2 divided by x minus 3. Okay, so in this question, the given is a is nothing but our x values, right? A is nothing but domain. So all x values. So x values are real numbers but not equal to 3. Right? If I am taking x is equal to 3, 3 minus 3 is equal to 0. So the y should be infinity, right? Next, b is nothing but our y values, right? So that is given as real numbers but not equal to 1. So if y is equal to 1 means 1 minus 1 equal to 0. So the whole x values are infinity. So it is obviously showing that our codomain and range are equal only. So f of x is equal to y. So we can prove this side also by putting this x value in this y. So x equal to 3y minus 2 divided by y minus 1 by minus 2 divided by 3y minus 2 divided by y minus 1 minus 3. This is y, right? Y is, we can write y equal to f of x, right? F of x. So by taking LCM y minus 1, 3y minus 2 minus 2 into y minus 1. So here also I am taking y minus 1 LCM. So 3y minus 2 by cross multiplying this minus 3 into y minus 1. So we can cancel this y minus 1 and this y minus 1. So my multiplying minus 2 inside, 3y minus 2 minus 2y plus 2 divided by 3y minus 2 minus 3y plus 3, right? So 3y minus 2y is nothing but y. Minus 2 and plus 2 we can cancel, right? Divided by this 3y and minus 3y we can cancel. So 3 minus 2 is 1. So equal to y. So f of x is equal to, we proved that f of x is equal to y. Therefore this function is onto function. So this given function is 1 to 1 and onto function. Next, 11th question. So in this question the function f of x is given as x power 4. We need to check this function is 1 to 1 and onto, and we need to choose the correct answer from these 4 options. Okay, so these are simple only. So here domain and codomain are real numbers. Okay, so f of x is equal to x power 4. This is given. So for 1 to 1 function we need to check f of x1 is equal to f of x2 means x1 is equal to x2. We need to check this condition. Okay, so f of x1 is nothing but x1 power 4. F of x2 is nothing but x2 power 4. Okay, so while power this 4 to be while taking this power to this side, so x1 is equal to plus or minus root power 4 x2 power 4. So so this root and this power will be cancelled. So x1 is equal to plus or minus x2. So we need to prove x1 equal to x2, but here x1 is equal to plus or minus x2, that is plus x2 or minus x2. So two values, right? So two values. So this function is not one to one function, right? So this function is not one to one function. Next we need to check this onto. So for onto, we need to prove that f of x is equal to y, that is nothing but codomain is equal to range. We need to prove codomain is equal to range, right? So if this function given f of x is x power 4, right? So first we need to check whether we can able to find the range of this function. So we can find a range of this function means, see, it is easy to check the codomain is equal to range. We can't able to find the range of this function means we need to prove f of x is equal to y. So we need to prove in equation. But here we can easily find the range of this function because x power 4, this is the f of x, this is our range, right? F of x is equal to x power 4, this is our range. So x power 4 means if I am taking any values for x, I am taking minus 2 means minus 2 the whole power 5 should be positive value, right? If you taking any x values, but answer should be a positive. So range of the range nothing but 0 to infinity only, right? 0 to infinity. If I am taking any value of x, the output f of x should be a positive value because the power is 4. So I am taking any number, it should be a positive value. So the f of x range of this is 0 to infinity. But our codomain is all real numbers. So all real numbers means it should be minus infinity to infinity. Right, this is all real numbers. So all real numbers means minus infinity to infinity. But our range is only 0 to infinity. So this is not equal to range. So this function is not onto function. So therefore the function is neither one to one nor onto function. So answer is option D. F is neither one to one nor onto. So next question number 12. This function, in this question the function given as f of x is equal to 3x. So we need to check this function is one to one, onto, or many to one, anything. Okay, so first for we one to one. 1 to 1, we need to satisfy f of x1 is equal to f of x2 tends to x1 is equal to x2, right? X1 is equal to x2. So here f of x1 is 3x1, f of x2 is 3x2. So cancelling this 3, x1 is equal to x2. So easily we proved x1 is equal to x2. So this function is 1 to 1. Okay, so this function is one to one function. Next we need to check onto. So for onto, we need to satisfy f of x is equal to y, right? F of x is equal to y means codomain is equal to range. So if we can calculate the range of this function, f of x is equal to 3x. So x values are all real numbers. So it will be goes on infinity. So we can't able to find the range. So we need to prove f of x is equal to y. So y is equal to 3x. So by calculating x value, x is equal to y by 3. So by putting x is equal to y by 3 in this function, f of x is equal to 3 into y by 3 is equal to y. So f of x is equal to y. We proved f of x is equal to y. So this function is onto function. Otherwise, we can easily understand this function because all x values are real numbers. So f of x values is equal to 3x. So multiplying 3 into all real numbers, output will be a real number only. So codomain also real number, range also real number. So it is equal only. So f is equal to onto function. So this function is 1 to 1 and onto function. So what is the answer in this options? F is onto and 1 to 1. So A is the answer. Okay. So we completed all the problems in exercise 1.2. I hope you understand all these problems. If you having any doubts means kindly comment in comment section. Thank you students.